Okay, so in this example, we're going to do 4 examples where we show various different combinations of surjective and injective. So now we're on to the example where we're going to show something is surjective but not injective. Okay. Now for this example, I have to do something funny, which is, since we define the natural numbers to not include 0, sometimes we want to include 0, so I'll have to just union 0 back into the natural numbers, which is what I'm doing, which makes the notation a little bit cumbersome, admittedly. Excuse me. But it's okay. So the function goes from the natural numbers union 0 cross the natural numbers union 0 to the natural numbers union 0. Okay. If we included 0, we wouldn't have to do that, but we didn't, so it is what it is. It's okay. And let's see how we're going to do this. So first of all, let's just make sure that you're comfortable with the function. So let's just plug in a few values. So if I plug in, 2 comma 3, then I get 2 plus 3, which is equal to 5. If I plug in 0 comma 4, I get 0 plus 4, so on and so forth, right? So for surjective, I just need to show that every value in the codomain is hit by something in the domain. I don't need to show you everywhere, everything that hits the value in the codomain. So it's easy to just pick, if you consider f of 0 comma n, that's going to be 0 plus n, and that's just going to be n. And you can let n be anything in the codomain because the domain is the natural numbers union 0, right? So this is like for all n in the natural numbers union 0. So that's going to get us surjective, right? And to show that it's not injective, we just have to pick 2 different values in the domain that get mapped to the same thing, right? But we know that addition of n plus m, of course, can give us, for instance, 3 in several different ways. It could be other things too, like for instance, f of 1 comma 2 is 1 plus 2, which is 3, which of course is equal to 2 plus 1, which is f of 2 comma 1. But 1 comma 2 and 2 comma 1 are not the same, right? So again, I'm just playing around with how to do this. And so now let's get into the actual proof. This one is one of the quicker proofs that we've done of showing this for functions. So to show that f is not surjective, notice that, well, notice that n comma 0 is in, just want to make it clear, sorry, not cross, but union 0 cross n union 0. So we're just saying, this is in the domain, and f of n comma 0 is equal to n plus 0, which is equal to m for each n in in the natural numbers union 0. Okay, so that's it. That's what it means to be surjective. Everything in the codomain is hit by something in the domain, right? So hence f is surjective. Okay, to show that f is not injective, notice that 1 comma 2 is not equal to 2 comma 1, but f of 2 comma 1 is equal to 2 plus 1, which is equal to 3, which is equal to 1 plus 2, which is equal to f of 1 comma 2. And that's it, right? So hence f is not injective. right? So again, for injective, to show something's not injective, we just need to pick two different values in the domain, which we know are not the same, and show that the image of the function is the same. Okay, so that's our third example. And the last example, we're going to show that a function is a bijection, meaning that it is injective and it is surjective.